Hi everyone, we'll get started here. Hopefully you can all hear me well. Webinar today is going to be focused really on accelerating Tableau when connecting to big data. And the topics we'd like to discuss here. Quick introduction of who is Jethro. We'll talk about Tableau and big data, the two methods Tableau uses to extract or access data in databases. Then we'll zoom in to big data platforms, Hadoop versus EDW appliances. And then we talk about database architecture, the two architectures commonly used for analytical databases, full scan versus index access. What we'll do next is a live demo. We'll show a Tableau application running over 3 different SQL engines, Impala, Redshift, and Jethro, and compare and contrast performance and what's behind the scenes. And then a few more minutes about how Jethro for Tableau works and how it accelerates performance. The plan is to spend about 30 minutes on the slides and the demo and then leave about 15 minutes for Q&A. You can type in your questions as we go. There should be a Q&A window on your screen. So feel free to type in questions. We'll try to answer them during the presentation, and whatever we cannot, we'll just leave till the end and handle it at the end of the session. A few words about myself and Jethro Data. My name is Eli Singer. I'm the CEO of Jethro Data. You can contact me with an email or phone. My background is technology. I used to be a database person for many years, and the last 20 years I've been focusing mainly on leading startups, technology startups. What Jethro does is that we build a SQL engine that's really focused on one use case, BI on big data and how to accelerate it. So it's very narrowly designed to address that need. What we did technically, you can think of it on the one side as a columnar database design, say like a Vertica, and then we combined it with search indexing technology, like in Elasticsearch. So in a way, it's a vertical Elasticsearch all in one product. That's what Jethro is trying to be. And what that let us do is on the one side look like a SQL database, but on the other side have the power and performance of full indexing. We've been working on that for almost 3 years, released the product to market last quarter. It's available to download on our site, and you can evaluate it for free. The main use case for Jethro is what we refer to as the BI spinner syndrome, is when you sit in front of your BI tool and you have this spinner and it's spinning and spinning for long minutes. That's typically the indication of where Jethro comes in. It means that the BI tool cannot handle, and the database behind it cannot handle the size of the data, and performance suffers. So that is the main problem that we solve. We work closely with Tableau and other BI vendors. We also work closely with Hadoop vendors. So we see ourselves as the connection and the intersection of BI and big data. So let's get into it. Let's talk about Tableau. And the main way people use Tableau is the extract and in-memory. Essentially, we have Tableau. You identify some data in a remote or external database. Use Tableau to define the extract, which columns and which rows you want to have. That data is being extracted and then loaded into your Tableau system, your desktop or your server memory. A lot of Tableau optimization is about loading partial columns and partial rows. But at the end of the day, this approach has a limitation. The main limitation is performance starts to degrade and scale is limited. What we typically hear is when you get to 200 million rows, that's pretty much the area where bringing data into Tableau has its limit. So this is not a new problem, and what Tableau has been doing is to provide an additional way to access data through something called Live Connect. In this case, Tableau does not bring all the data in, but rather issues SQL queries to the database. Every user interaction results in SQL queries. Those are sent to the database. The database does the data filtering and aggregation and sends the results back to Tableau. The limitation of this approach is that now we depend on the performance of the underlying database. And typically, that is not going to be as fast as your in-memory Tableau. But these are the two options that we have. And let's talk about Live Connect. That's what we're going to focus about on today. And as I said, this is not a new thing. For a long time, we've been using Live Connect, mainly pointing it at large EDW appliances, the Teradata and Netezas and Exadata and so on. And it's been working to a large extent, working fairly well with some limitations, but obviously the world has been progressing forward. What's happening in the last few years is an interesting phenomenon. What we're trying to do is we're trying to keep the application layer, the analytics, the BI layer intact, but change the data platform underneath it, going from the EDW appliances towards Hadoop-based platform. This is driven by the size of the data. We want to push much more data into our analytics platforms, the cost, and the promise of open platforms. And that shift is something that we're seeing accelerating, and it's pretty clear that with all the challenges and difficulties, there's probably no going back. However, just like any other technology, Hadoop comes with its own technology trade-off. And in Hadoop, what we get is scale and lower cost per storage unit. What we pay for is performance. And think of it for a second. It's not realistic to expect to get the same performance when we push in 10 times more data and replace the highly optimized hardware that comes with a Teradata or a Netezza with commodity boxes. You're just not going to get the same performance. It's as simple as that. And if we look at Hadoop adoption and Hadoop success so far, it's definitely been going from the slow workloads to the faster ones. We're seeing ETL, predictive machine learning reporting. These are all things that ported fairly well to Hadoop. Hadoop's performance trade-off becomes very clear when you try to point your BI tools at Hadoop. When you point your Tableau at a large data set in Hadoop, most likely you'll realize that it's just way too slow for interactive analysis. If we look deeper into it, what is the reason why it's not fast enough? It really comes down to database architecture. Every single SQL on Hadoop tool uses an architecture called MPP full scan. It's the same architecture also used in EDWs outside Hadoop. And to understand how it works, let's use an analogy of a library. Think of a large library that has billions and billions of books, that has thousands of recs, and for each rec we have its own librarian. And then a person walks into this library and asks for the list of books by Stephen King. And what happens next is that each librarian will go to their rec and start pulling book by book by book. And each book that they pull, they check if the author is Stephen King. If so, add it to the list, and if not, go to the next book. That is what full scan MPP process is like. Obviously, when you think of BI use case where queries tend to be selective, like the example I had here, it makes very little sense to go and scan billions of books if we just look for several hundreds. But that is the architecture. Now, the alternative architecture is index-based access. What if we index all the books in this library, index every single attribute of them? The title, the author, the publisher, the color of the book cover, everything that we can. When we have an index and get the same query, it's very simple. We just go to the index of authors, entry Stephen King. It would tell us that we need to get books 1, 2, 5, and 10, and we just go and pull those books. We don't have to go and scan billions of books to find those 4. That is how index access works for BI use case and why it's much optimal for it. To put it in a little bit of perspective, if we look at the market, in the Hadoop space, there's about a dozen SQL on Hadoop tools. Some of them were Hadoop native, like Hive and Impala and Presto. Some of them were ported from EDW, like Hawk and Actin and IBM Big SQL and even Vertica. And there's probably another half a dozen or a dozen analytical databases that have nothing to do with Hadoop. They all use the same architecture. They all use full scan. They're all librarians. Jethro took the other approach, and what we have done is build a full indexed instead of full scan solution. And it's not that one of us is right and one of us is wrong or the others are wrong. It's really about the use cases. For BI use case, where queries tend to be selective, where users drill down, index access tend to perform better. For other use cases, like predictive or machine learning, reporting and so on, NPP full scan tends to perform better because we're going to end up accessing most of the data anyway. So it's really a choice of an architecture and a choice of a use case. And that's why we focus exclusively on the BI use case. Now, what we've done next is to put together a live demo. This is going to be publicly available later today. You'll be able to access it yourself at tableau.jethrodata.com. The user ID and password are demo. And what we did here is we took data from an open source benchmark called TPCDS. We generated data at a 1 terabyte factor, and that generated a 400 gigabyte fact table. That fact table has about 2.9 billion rows, and there are about 7 or so dimensions that go with it. And what we did next is we took the same data set and put it into those 3 different tools. We use Redshift and put it into Redshift. We then took this data set, stored it in a Parquet format, and put Impala on top of it. And we do the same thing with Jethro for an index data set. You have here the list of hardware for each one of those setups, both the Hadoop cluster and the compute cluster, the total RAM and CPU, and even the Amazon, the AWS hourly cost of each one of those setups. So I'm going to go now to tableau.jethrodata.com and show you what we have here. On this side, we have the Jethro application in Tableau. And then here we have Impala and we have Redshift. They all use the same Tableau application, exact application. They all use the exact data, just the different SQL tools that run it. If we start with Impala and we start a simple drill down, just select one of those quick filters that choose year 2000. And what happens now is that Tableau is issuing about half a dozen queries for all of those charts in this dashboard to get the data. Those queries go to Impala. Impala then does a full scan on the Hadoop cluster on Amazon, and the response will go back to Tableau. We'll do the same thing with Redshift. Choose, again, year 2000 and let it run. The queries are somewhat different because Tableau issues optimized queries for each of those data engines. And then we go here to this side and do the same thing with Jethro. Choose year 2000. As you can see that in the Jethro side, the response was pretty fast. On the top right, we had the number of rows in the table. After I added the year 2000 filter, it went down from 2.9 billion to 553 million rows. If we continue our drill down, choose a product category like jewelry, same thing happens. Tableau issued multiple queries to Jethro. Jethro used the indexes to filter down which rows we need, and now we only needed 54 million rows. We can continue doing that, choose one of the states. Again, it goes to Jethro, choose customer credit rating. I'm just kind of randomly trying to choose things here. And you can see in Jethro, queries take anywhere from 5 to 10 seconds and so on. If we go back to the other 2 tools, this is Redshift, it's still working. Oh, Impala finally came back. I'll do the second filter here in Impala, choose the product category. Typically what we see is that queries in Impala take anywhere from 1 to 2 minutes. Queries in Redshift take similar time, while in Jethro they take usually under 10 seconds. Interesting phenomena though, as you add more and more filters, in Jethro, queries become faster and faster because the filter narrows down your working set. In Impala and Redshift, every filter we add tends to make the query run slower because now there's more data to be scanned. Same thing we see with multiple users. As we add more users or more concurrent sessions in Impala and Redshift, queries tend to deteriorate very quickly, while in Jethro the impact is much smaller. We can look at the Impala log here and see that queries typically take 60, 70 seconds or more. 57 seconds, 55, and so on. Same thing, we can look at the Redshift and see the... but you get the sense of it. Each of those queries can take a minute or 2, and then when you have multiple queries, they start slowing each other down. So that's what we have in terms of demo. You can play with it yourself and get the sense of performance. and this will be open publicly starting later tonight or tomorrow. So let me continue with the slides, and let's talk about what's happening behind the scene. And I'll focus, in this case, on Jethro. So what is Jethro? Jethro can be viewed as an indexing and caching server for Tableau. The way it works is pretty simple. You've got your Tableau on top, and you've got your data sets in an enterprise data warehouse or Hadoop or something else at the bottom. What you do first is you find those data sets that you want to expose to your Tableau users. Not everything you have in your EDW or in your Hadoop is BI worthy. Those data sets you will extract from their source and then pass to Jethro caching server. What Jethro will do then is index those data sets or those tables, fully index them. We index every single column, and then store it back at whatever storage platform you want Jethro to use, Hadoop or a cloud storage or local file system. Then Tableau connects to Jethro using an ODBC. It issues live connect queries, and as you saw in the demo, those queries get processed fairly fast. If we zoom in, let's talk about the first step, selecting data for Jethro acceleration. Again, not everything in your Hadoop, not everything in your EDW requires this acceleration. It's only those data sets or those tables or sub-tables that are really BI worthy and really the ones that you need to get higher performance for. You can use any ETL tool that you have to extract the data, and then you pass it on to Jethro using a CSV file format or any delimited file format. You can pass it as a temporary file or just pipe it to Jethro live. Jethro will then go through the processing, create its index files, create its column files. Jethro creates its own version of the table and then stores it back in whatever storage you have, HDFS, local file system, cloud storage like S3, or network storage. The process is pretty fast. Jethro can load data, can ingest this data at about 1 billion rows per hour. So a table of, say, 2 billion rows will take a couple of hours. From that moment on, you can do incremental loads every minute or every hour or every day, and those will take seconds or minutes to do. Very easy to update Jethro that way. In terms of sizing, a terabyte of raw data is likely to result in about 300 to 400 gigabytes in Jethro, including the data and the indexes, so about 1/3 to 40%. Now, once we have the data, how does Jethro process queries? So in this case, let's assume the data is in HDFS and there are 5 data nodes. What will happen is that the data will randomly be split across those 5 nodes, both the indexes and the column data itself. The Jethro query nodes, those Jethro servers, don't run inside Hadoop cluster. They run as their own separate servers, edge nodes as we refer to them. You can have one Jethro query node, you can have multiple Jethro query nodes depending on your concurrency and size of your data and other factors. Now, when Tableau sends a query to Jethro using ODBC, in this case, summarize sales for product ABC, what Jethro does first is to analyze the workflows. We look and it says product ABC, so we're going to open the index for column product, go to entry ABC, figure out which row IDs have that value, and send it back to Jethro. And then Jethro is going to go and read the column data, the sales data, but only for those rows, not for all the rows in the table. We get this column data, we do the aggregation, and back to Tableau. Now, the nice thing about it is that performance here is really based on the size of your working set. If there are a million rows for product ABC, and it takes 5 seconds to get and process them, that query will take 5 seconds regardless of how big the data set is. If the data set is 1 billion or 5 billion or 20 billion, it would still take the same 5 seconds because Jethro does not read data that it doesn't need, it only reads the data that this query specifically needs. Next, I want to spend a few seconds on Jethro Indexes and explain that technology. Obviously, a lot of the strength of Jethro comes from the fact that we index the data. We index, again, every single column. So regardless of what query it is and what filter the user used or what aggregation they do, there's always going to be an index that we can use here. The indexes logically look like inverted lists. So we have the list of values of each column, and then for each of those values, all the row IDs where that value can be found. There is a lookup table or an index of an index. So when you're looking for a specific value, Jethro does not need to scan the entire index, does not need to load it into memory or all those things that you might remember from databases. We actually have this lookup table that gives us a direct pointer to where each value starts in the index itself. The index can scale to billions and billions of rows. It uses hierarchical compressed bitmaps as its technology, and its footprint is fairly small. So that's what makes Jethro Indexes very fast to read. There's also a lot of attention being paid to how Jethro Indexes get updated. If incremental data is being added every few minutes, and this happens throughout the day, what may happen is that new rows that come in might have existing values. In this chart here, we show that we are loading another batch of rows, and the value FR for France is repeated. Now, in traditional indexes, you would go to the original index entry, go to the end of it, and try to push in the new row ID that just arrived. However, that is typically a very expensive operation. It requires locking of the index, it slows down reads, and causes a lot of disturbance in the system. So in Jethro, we work differently. The indexes are appendable, just like the column files. So when new data comes in, we just add the index entries for that data to the end of the existing index, even if that means that you're going to have the same entry duplicated. Now, duplicate entries cost very little because the index of the index let us find all of them very fast. So what we can do here is we can load data continuously, don't affect performance of existing processes, read processes, and pay a little penalty on performance. And lastly, we have a background process that sits there, and when it figures that the index got too fragmented, it would then just go and read all those fragments, all those index components, and merge them into one coherent index that has no duplicate. This is a background process, it's a read-only process, it doesn't affect performance of anything else, and when it's done, it just flips a switch and says, here is now the updated index, and Jethro will start using the updated index from that moment on. So this capability is really what made Jethro very successful here, because now we can index literally every column. We don't see the cost of indexes on performance when indexes get updated, and then we get the benefit of index every time a user or Tableau issues queries. Lastly, I'm going to mention one more Jethro feature, and that is our adaptive optimization. Jethro knows how to cache results of queries. Now, if we think of it, think of your dashboards. When users start their exploration of a dashboard, they usually start at the top. The queries are very wide, there are no filters. And those are fairly expensive queries in Jethro because we don't get any benefit from the indexes here. The good news, though, is that once those queries are run the first time, the results are cached, and all subsequent users just want to get it immediately. Now, the way it works nicely here is that those very expensive wide queries are also very repeatable. When you have no indexes, no filters, the query is very generic. It's very easy to cache it, and it will repeat very often. As users drill down, add their own filters, queries become more and more unique and harder to cache, but that's when the indexes kick in. So between having the cache for the very wide but very repeatable queries, and then having the indexes for the very unique but also very selective queries, we get pretty consistent response time across the range. If you go back to the Jethro demo that I played with earlier, you probably find it difficult to see when a query was returned by cache versus selective index. One more thing to say about it is that This query result cache is also stored, by the way, in HDFS, not on the Jethro servers, knows how to maintain itself across incremental loads. So when new data is being loaded, we don't invalidate this cache, but when we get a query repeat, we'll just go and rerun this query only on the incremental delta of the data, and then merge those results with the cache results from before, and that will become the new results of that query. So I talked a lot about how it works in technology. Let me do a quick summary and talk about why index access really works best for BI. And here are the 5 reasons. The first of all, and most importantly, we use the indexes to eliminate the need to read massive amount of unnecessary data. If we know which rows we need, we can just go and fetch those rows. We don't have to go and read everything else. As you're probably familiar with a lot of the MPP full scan tools, they commonly often use partitions to minimize the data that they read. That works for those queries that use a partition key. It doesn't work when a query is cross-partition. In the case of Jethro Indexes, it's almost as creating a partition key for every single column. So every column is indexed. We don't have to be limited to a specific partition key that's been defined. Second thing is that the deeper you go, the faster it gets. As users drill down and add more filters, the queries become more selective, and indexes make them much faster to retrieve the data. There is unlimited flexibility. Users can aggregate on any filter, any column, aggregate and filter on any column. They don't have to always use a specific key, a partition key or sort key. They can do their job and their own exploration. There's always going to be a filter or an index that would help them get the performance they need. Next, we have concurrency. BI tends to have large amount of users, and each one of those BI dashboards generates a huge amount of queries. That load is something that plays very well into repeatable queries. If everybody is starting at the same point, the query is going to repeat themselves, and that results in very high cache efficiency. And lastly, Jethro can actually shield the BI workload from everything else that happens in the analytics, in the cluster. So other analytics like ETLs or predictive analytics running on the same cluster usually clash with BI. In this case, Jethro only accesses selected data from the cluster and does all the processing outside the cluster. So you don't find yourself having to double the size of your cluster or double the memory on each one of those nodes. It's really simple. BI is not affected by the rest of the cluster and vice versa. So this is really kind of where it comes down to. If this is interesting enough and you find it valuable, you can just go to jethrodata.com and /download Jethro for Tableau. We have currently a Unix-based version that's available for download and trial. We're working on a Windows-based version that you can sign up for its beta program. Once you register, what we typically do is we schedule a POC call with one of our solution engineers or solution architects, go through your data and application, go through your needs, and be able to tell you very quickly if Jethro is going to be a good fit for your environment. From there, it's really very simple. One-time setup, you download the software, you install it on a server, you start the services and configure it, extract some data, load it into Jethro, and then you just connect Tableau with an ODBC and start querying around. Typically takes a few minutes and you're ready to go. So that's what we prepared so far. And if there are any questions, we'd love to try to answer them. Let's see if I can. So the first question is about using full scan and Jethro side by side. So some clarification here. First of all, Jethro can definitely do a full scan. So depending on the query, depending on the underlying data, Jethro dynamically decides if indexes are the best way to go, or full scan will be cheaper in this case. So you can definitely mix full scan and index access within Jethro. If your use case is such that most of your work is full scan oriented, then we recommend that you use two different engines. You use one engine for your full scan and one for your BI access. We actually had this question from a prospect earlier today. They do an ETL which creates a session information. And the recommendation was use that process the way you do it right now. The outcome of that process is the table that you would push into Jethro, the incremental data you push into Jethro, and that's where you're going to point your BI onto. If the question is about Jethro itself being able to dynamically serve some queries or offload them into another tool, that is something that we're probably going to look into next year, but not something that we are working on right now. Next question is about Jethro. Is it exclusively working with Tableau, or can it work with other BI tools? And the answer is that Jethro can work with any ODBC or JDBC-based tool. So we work with several BI vendors, and we also connect to many SQL clients as well. So not limited to any specific tool. What we do with Tableau is we have a Tableau TDC file, which is a special customization for Tableau. And what we do also is BI tools that we work closely with, such as Tableau and Qlik. We build some optimizations in the database to deal with queries that we see coming from those tools. So there's some optimization that Jethro built in based on what Tableau generates. But you can definitely use Jethro with any BI tool that you have. The next question is about getting data into Jethro, and this is currently probably where the most work needs to be done from a user application perspective. So let's say you have your data in a Hive table in Hadoop, or you have it in a Teradata table. Whatever ETL tool you use, in the case of Hadoop, people just simply do a Hive job that has a select star. So you run a query to extract the data from the current source, and then the output of that query is a file that is then being fed to Jethro. Feeding into Jethro is very simple. It's currently a command line process that you just call a Jethro service called Jethro Loader. You give it the input file, a description file of what the input looks like, and that's really all there is to it. So it's a pretty simple process. Can be integrated easily with any ETL tool that you might have, or can be done with scripting just as simply. Hopefully in the future we'll be able to connect to BI tools like Tableau and Qlik and use their extract process and just piggyback on top of it. So hopefully at one point when the relationship becomes even closer, you might be able to use a BI tool extract and then have the output be fed automatically to Jethro. Next question is about Jethro working with different data repositories, and I'll answer it this way. On the input side, where you extract data and feed into Jethro, of course, any source is welcome. Can be your EDW, can be your Hadoop, can be Excel, whatever the case might be. You just need to create a data set that Jethro can then ingest and take in. On the other side, where Jethro's data is being stored after Jethro processed the input and created the index files and the column files, this can be stored on multiple systems. HDFS is one place that we typically see for large tables, but it can also be stored in a local file system, can be stored in a network file system, if you have an EMC or one of those systems. Can also be stored in cloud storage like an S3 or Amazon EFS. So Jethro can store its data pretty much anywhere that you have. The one place it cannot store it is in EDW. So we cannot store Jethro's own data in Teradata. Another question we had is again about ETL from DB to Jethro. Hopefully I answered that. So again, it's very simple. You just do your extract from your database and back into Jethro. I have one more question here. There's one more question about ETL performance into Jethro, and the answer here is it takes, well, multiple steps. So you have to extract it from the original database, if it's a Hive or if it's Teradata or Oracle, as long as that takes. The ingestion into Jethro is pretty fast, as I mentioned earlier, about 1 billion rows per hour. So your initial load will take a couple of hours perhaps, maybe a day if you have a huge table. But from their moment on, every day you probably add several tens of millions, hundreds of millions. That would take a few minutes only to do. I have a question about Kerberos security. Jethro knows how to work with Kerberized Hadoop cluster. So if your Hadoop cluster is Kerberized, Jethro can work with it. In terms of security inside Jethro, we currently do not support Kerberos authentication for users of Jethro. So Jethro itself can work on a Kerberized cluster, but we don't have Kerberos inside Jethro yet. There was a clarification question about where Jethro stores its data. So if you use HDFS as your distributed storage for Jethro, then Jethro will just throw its files, index files and column files in HDFS, and then Hadoop will just manage those files, put them anywhere it likes, treat it as any other type of binary files in HDFS, and then Jethro connects to the Hadoop cluster using a simple HDFS client, and we just talk to Hadoop at an API level. All right, I think, let's see. Oh, I'm sorry, there are a few more questions here. Data can be exported from Jethro. The answer is absolutely. Just like any other database, you can do a select from Jethro and pipe it into any other destination that you want. Maybe I'll answer perhaps a wider question here in terms of Jethro's data interoperability. So right now, Jethro stores data in its own file format. If you want to extract from Jethro or export out from Jethro, you just use SQL to do that. In Hadoop world, there are some file formats that might be suitable for Jethro as well. One of them is Parquet, the other is ORC. So it's possible that in the future, Jethro's column files will share a data format such as Parquet and ORC. Jethro's index files will very likely always remain specific to Jethro. I missed a question from earlier, which is an important question about Jethro nodes. So Jethro servers are all elastic, which means none of the data is kept locally. Everything is kept in your shared storage. Once you start a Jethro server, it just connects to that storage, let's say HDFS, and start pulling data from there. If you have high concurrency, you can add more and more Jethro servers. They all look and access the same shared storage. So there's no need to mirror data between them. You can have multiple Jethro servers all pointing to the same shared storage. They will build some local caching, server-side caching for performance, but this is all temporary data. So definitely have elastic Jethro servers. And I think that's all the questions that we see, and we're coming up on 45 minutes. Oh, sorry, there's one more question here. Yes, the question is about the use of Jethro query nodes. Those query nodes are compute nodes only. They're only there to process the queries. The data is always stored in the shared storage, and these are pure compute nodes. There's a question about concurrency. How many concurrent users can a single Jethro node handle? And it's usually a pretty hard question to answer because it depends on many variables. It depends on how big the Jethro server is. A 64 gigabyte machine with 4 cores is going to be much smaller than 256, for example. Another variable is really how active those users are, how many concurrent queries they generate, because Jethro only cares about concurrent queries. Another question is, those queries, if they come from a dashboard and a lot of them are repeat queries, we can handle many more, so on. So it's hard to give an exact number. What we typically say is that we expect the Jethro server to comfortably handle 10 to 20 users. It might be able to handle many more, sometimes less. If you see that queries start to back up, you just add another Jethro server. It doesn't require any data rebalancing or data shuffling, all those things you have to do with MPPs. It's a simple compute node. You just fire it up, and it's ready to go from that moment on. Jethro clients automatically know how to share the load between the Jethro servers, so you don't have to worry about that as well. There's a question about loading data directly to Jethro. The answer is absolutely. There's already some use cases where data can come in on a message bus, and then there is some process that collects some or buffers some data and creates some micro batches. So you can definitely connect Jethro to any source. Data can be packed into Jethro. Doesn't have to be a physical file. What we typically say is that you want to create micro batches. You don't want to load one event at a time. You want to collect some kind of scale of events. That's mainly coming from HDFS block size limitations. But it's nothing inherently in Jethro that prevents you from doing very small micro batches fairly often, as I would say it's close to it every few seconds. But definitely drawn the line, Jethro is not an event processing tool. We don't work at an event level. We'd rather you batch together a few thousands, a few hundred thousands of events and give it to Jethro so we can be efficient. I think we might have answered all the questions. Oh, sorry, one more question I see here. Does Jethro client needs to be installed on storage server? Good question. No Jethro component needs to be installed on your Hadoop cluster, if that is your storage system or your EMC storage or whatever. Jethro only installs on its own server. It's Jethro compute server, compute nodes or query nodes. And we talk to storage using whatever storage API exists. So in Hadoop, we use HDFS. If it's Amazon storage, we use S3. If it's a local file system, we just use the POSIX API. So Jethro does not need to be installed on your cluster machines. Yes, Jethro is native to Linux. The version that is available for download from our site today is Linux-based. We are working on a Jethro Windows-based version, which will be more typical for Tableau users, and just opened registration for beta for that version. So it's probably a few weeks out. So Linux is available today to download and try. Windows beta registration starting now. All right, I think we got all the questions done and squeezed it in the 45 minutes that we hoped to do today. So I really want to thank you for the time and the questions and the interest. Last question came in about native connection for Tableau. Not yet. Right now we use generic ODBC, but we found that to be just as efficient. So thanks again for the time and the question. We look forward to connecting with you, and have a great weekend.